the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on our videos.
Hello, good day everyone. Today we're going to have a tutorial on the course CE3401, that's Physical Transport Phenomena 1, and we are going to solve a question under convective heat transfer. Okay, so this is the question. Let's read it together and bring out the data and the question, then solve it all together. The question states that a 3/4 inch steel pipe having an internal diameter, okay, so here we are given internal diameter to be 0.0687 feet and an outer diameter, we are given the outer diameter to be 0.0875 feet, has a saturated steam at 267 degrees Fahrenheit flowing inside. Now the temperature that's flowing inside, the temperature of the steam, Ti, is equal to 267 degrees Fahrenheit. With 1.5 inch of insulation on the outside. So let me say this is the diameter of the insulation. Yeah, assuming this is the pipe here, this is the internal diameter, this one I'm cycling again, and this one is the green cycle, is the outer diameter. So the interface between this internal diameter and the outer diameter is given to be 1.5 inch. We are going to use it when solving our question. And the convective coefficient for the inside steam surface of the pipe is, okay, convective coefficient for the inside surface, Hi, is given to be 1000 BTU per hour feet square degrees Fahrenheit. And the convective coefficient in the outside of the lagging is estimated, okay, for the outside, H outside is estimated to be 2 BTU per feet per hour feet square degrees Fahrenheit. The mean thermal conductivity of the metal, okay, let the metal be Ka or K, 26 BTU per hour feet, this is feet. And for the insulation, the thermal conductivity for the insulation, that's since the insulation is the outer, I can say K naught is given to 0.037 BTU hour feet degrees Fahrenheit for the insulation. We are told to calculate the heat loss for a unit length. This is an area of the pipe. The length of the pipe you are given. We are told unit length in feet. So the area is unit, that's 1 feet of the pipe. Using resistances. Okay, we are going to use the resistances to calculate it. If the surrounding air, okay, let's say the surrounding air, this is T of the outside of the surrounding is what? 80 degrees Fahrenheit. Okay, we have all the data to calculate the resistances, as we are told. Q, T of the inside, minus T of the outside, all over the resistance of the inside plus the resistance of the material A, which is our metal now, plus the resistance of material B plus the outer resistance. Wow. We have to calculate all these resistances. Ri is going to be 1 over, we are given this coefficient, convective transfer coefficient, times AI, internal area. Ra is going to be calculated from the radius minus Ri. divided by Ka, that's the thermal conductivity of material A, times log mean area of A log mean, where A log mean is this A log mean is nothing but A1 minus AI divided by ln of A1 divided over AI. This is A1 over AI. This is what we will use to calculate the log mean area, and then from that we can calculate the resistances. So RB is going to be R naught, the outside radius, plus R1 all over RB AB lim. Okay, log mean area of that B. This is KB lim. That's a log mean area. Log mean area of B. That's A naught minus A1 divided by ln of A naught over A1. All this A1, AI, and A naught, I'll calculate them from the data I'm given, will come. And then finally, this R naught, the resistance R naught, I'm going to calculate it using 1 over convective coefficient into A naught. These are all the formulas I'm going to use. So let me determine my A's, R's that I'm going to use to determine the resistances, because I already have the temperatures that I'll use for this equation of Q. So from the data here, I'm given the internal diameter to be 0.0687 feet. So the radius, we say Ri, is going to be that diameter over 2, which is what? 0.0687 divided by 2 is going to give me 0.03435. 0.03435. And then the outer diameter, I'm going to, let's say R1 for the outer diameter, it's going to be 0.0875 divided by 2. 0.0875 divided by 2, which is going to give me 0.04375. Outer diameter over 2 is going to give me what? 0.04375. All in feet. You can see that I have from my questions A naught, A outside, AO, and the rest. So to determine AO, I'm going to find also RO. That's the radius of the interface between the two diameters. That's, back to this diagram, we are told that the length here is what? 1.5 inch. 1.5 inch is the same thing as what? In feet. 1.5 divided by 12, which is going to give me in inch 0.125. That's 0.125 feet. And then the radius of the outer diameter also is what? 0.04375. Of this outer diameter is 0.04375. So I'm going, this R outside is going to be from the where my internal diameter ends to the outer part. Therefore, I will say RO is what? 0.04375. It's already in feet, plus 0.125, which is going to give me 0.16875 in feet. So these are the values. I know that area is equal to what? 2 pi r L, since it's of a cylinder. So I'm going to use all those three radius I've calculated to determine my area. Ri is 0.03435 in feet. Then RO is 0.16375 and then R1 is what? 0.04375 0.04375, all in feet. This one also is in feet. So area AI is equal to 2 pi LRI, which is going to be 2 times pi times what's my length? I'm told is for unit length always. L is 1 and this R is 0.03435. So what is going to be my area? After calculating, if you calculate it correctly, you see that it's going to give you 0.216 feet square. Likewise, this one is going to give me 2 pi r. I have 2 pi L is also 1. The R naught is 0.16375, which is going to give you what? 0.275 if you calculate it correctly, feet square. Then for the last one, that's the outer one called A1, is going to be 2 pi, this R1, 2 pi into 1 into 0.04375, which if you calculate it correctly, you're going to have 1.060 feet square. So now I have my A's, which I will use to calculate log mean temperatures. So from the formula above, log mean temperature of AA lim is equal to what? A1 minus AI divided by, this is AI, A1 minus AI over ln of A1 divided by ln of AI. I have all my areas. What's A1? 1.060 minus what's AI? 0.216 divided by ln of 1.060 divided by 0.216. If you calculate it correctly, you see that this is going to give you 0.244. Then for the log mean area of B, material B, that's AB, lim is going to give you, as we wrote above, A0 plus A1 divided by what? A1, which is going to be, I calculate this above to 0.275. Now to calculate my log mean area, since I have all the areas, A N is going to be what? A minus AI divided by what? Ln AN over AI. Now what remains for us, since we have the radiuses, we are going to determine the areas. So this first one, Ri, therefore AI is going to be 2 pi L Ri, which is 2 pi into the length is 1 feet given already, times the Ri, which is 0.034, this is 0.03435 feet, which is what? 0.216 feet square. Then A is what? 2 pi r. It is 2 pi into 1, that's my L. Then this R is 0.16375 feet. The value, if you calculate it correctly, you're going to have 1.060 feet square. Then the last one, A1, is 2 pi LR1, which is 2 pi into the length 1, and then the R1 is what? 0.04375. If you calculate this correctly in your calculator, you're going to have 0.275 feet square. So now the log mean areas. As we've said, from this areas we are going to determine the log mean areas. The log mean area of A is going to be A1 minus AI. We've written the formula above, divided by ln of A1 over AI, which is what? 0.275 minus dash AI 0.216 divided by ln of 0.275 divided by 0.216. Cumulatively, if you put it in the a calculator, you're going to have 0.244. Then the log mean area for material B, or for the B part, is going to give me what? This minus A1, we've written the formula above also, over ln of A0 over A1, which is what? This, I've calculated it above to be 1.060 minus this, that's 0.275 divided by ln of 1.060 divided by 0.275. Computing this, you're going to have 0.582. So with this, I can determine all my resistances. That's Ri, Ra, Rb, and Ro, or R0. So Ri, the resistance, we've written the formula above as what? 1 over the heat transfer coefficient of the inside times area of the inside, which is what? 1 over Hi is given in the question as 1000, then times what you just calculated before the log mean area. This is going to give you 4.63 10 to the power of minus 3 if you calculate it correctly. Then this Ri, then Ra, which is given by the formula of R1 minus Ri all over the thermal conductivity of A times log mean area of A, which is all this. I've calculated it, I found it, or some portion are given from the question. I just divide 0.04375 minus out of this 0.03435 divided by what's this Ka, the thermal conductivity of A is given in the question as 26. Then this log mean area we've just calculated, 0.244. So if you compute this correctly in your calculator, you're going to have 1.482 times 10 to the power of minus 3. Then for this Rb is going to be what? We've written also the formula above, minus R1 over thermal conductivity of B times the log mean area of B, which is going to give you what? 0.16875 minus 0.04325 divided by this. We are also given from the question as 0.037 into AB, we calculated it above as 0.582. If you calculate this correctly, the value is going to give you 5.805. Only thing that remains before we insert it in our equation is RO or R naught, that of the outside, which is what? 1 over the convective coefficient times area of the outside, then 1 over, we're given it from the question as 2, then this area we calculate it as 1.060, which is what? 0.472. So all in all, the h that I'm asked to calculate is equal to T into T inside plus T outside all over the sum of the resistances, that of B plus that of outside, which is this I've been given from the question 267 minus this also from the question 80, all divided by all these resistances that I calculate. That's 4.63 times 10 to the power of minus 3 plus 1.482 times 10 to the power of minus 3, extending this, I'll say plus 5.805, then plus what? 0.472. 0.472, this one. So this one, the above, is going to give me 187. If you sum all together, this below one is going to give you 6.284. 6.284. After calculating, if you compute it correctly, you'll see that your answer is 29.76 BTU per hour. This is the final thing we asked to calculate in the question. That's the heat loss. So thank you very much. For any misunderstanding or question, we are waiting for you in the comment section. Thank you very much.